watching my lesson on nets and 3D shapes. So in this lesson, we'll be focusing on what a net is, how it can use nets, and why they're important. So just from the title slide itself, you can probably tell what a net is, right? So here we have a picture of a cube. And here we have a net of a cube. So you can already assume that this makes a cube. And you'd be right. A net is basically a two-dimensional, flat-out version of the shape. And if you were to fold these sides up and over, you would end up with the shape of a cube, well, at least for this net. So before we begin, we need to know and go over certain key terms. For example, face, base, and edge, as well as vertex. A face, well, that's just the sides of every part of the 3D shape, right? So the faces are all the sides of a 3D shape. So this would be a face, this will be a face, this is a face, and so on and so forth on this side, and on this side, and on this side, right? So you're going to see 3 here, and so you have a total of 6 faces. Now, a common mistake students will make is they will forget that even though they can't see these sides exist. And so it's a skill that you need to develop and just keep in the back of your mind so that you don't forget that those sides are there, because it's such an easy mark to miss when I say how many sides are in a cube and you say, oh, 3. Or they would say 4 because they know there's a bottom, but they would forget this one and this one. Bases. Well, the base is a face on the bottom, right? So the most bottom face is the base. That's it. Edges. Edges are where 2 sides meet. So you can see that line right there. It's not a really good straight line, but you can see this line right here. And that would be called the edge. And the edge is where this face and this face meet. So it's where 2 faces meet. That creates this line or an edge. So if I were to ask you how many edges there are, you would count each of these lines. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, right? Not the best drawn, but it would have 12 edges. Then we have vertexes. Vertexes are when 3 faces meet. Vertexes are when 3 faces meet. Right? And so when you have 3 faces, you end up creating a point called a vertex, or basically a corner. The plural of a vertex is vertices. So if I said, what is the plural of a vertex? You would say vertice or vertices. So what is a net? A net is a 2D pattern that can be folded into a 3D shape. So looking at this, take like 30 seconds to think, well, what 3D shape can I make if I folded all of these sides up? Right? So if you were to fold this guy up, and this guy up, and this guy up, and then folded that would make the top, and that would go into the back, you would end up with a cube, right? So this 2D pattern can be folded into a 3D shape. And hopefully this loads. It always takes forever. Different patterns, different nets can be folded into the same shape. So we'll look at this animation here and you'll see that this shape can unfold in different ways and therefore create different nets. So that's a common one, right? And then it'll fold into a different one, like so. And so that also makes a cube. Even though it's a different pattern, it also folds right back into a cube. So looking at these, well, which one would be a cube and which one would not make a 3D shape? Right, so we already know this one, right? That one's pretty obvious. This one too, right? If you were to zigzag that pattern, sorry, it's just being delayed. If you were to zigzag this pattern, you would end up with another cube. Now, ones that wouldn't work would be this one, 1, 2, 3, 4, 5. We know that cubes should have 6 sides, or 6 faces, so this one doesn't work. 1, 2, 3, 4, 5, 6. Oh, this one has 6. So should it work? Well, if you fold this up, then this up, then this up, then this up, you have a leftover side, or leftover face, right? So this one wouldn't work. This one has 1, 2, 3, 4, 5 out of the 6, so that wouldn't work. And this one has 1, 2, 3, 4, 5, 6. Okay, well, why wouldn't this work? It has 6 sides. Well, as you fold this up and on the top, this would also fold and overlap. So this side would be empty. So this one wouldn't work. And so recognizing how these nets can be folded into 3D shapes is important to know whether or not you can make a 3D shape out of them. So why care about this? Why is this important? Well, the reason why this is important is it's important for making 3D objects in everyday items, right? For example, cans of Coke, not so much anymore, but now, not so much now, but before, cans of Pepsi, cans of Coke were basically printed out on aluminum as a net for a cylinder. Same with boxes. It would be difficult to just make them 3D, right? To transport 3D objects, they take up so much space. But if you make them flat and fold them, then you can save space and then make them 3D. So nets are important for manufacturing, making it cheaper, and making it easier to transport goods. So what kind of shape does this net make? Well, when you look at this net, right, you can see that if you folded this up, this up, this up, and this up, and then this on top, you would end up with a rectangular prism. I don't know if I can make 3D shapes, but basically what you'd end up doing is creating a shape basically like that. Now it's not going to be perfect because I'm doing this on a trackpad, but basically it'll look something like that. Right? So you'd make a rectangular prism. Well, this one is a different kind of shape, right? So if we were to fold everything up, we'd end up with, right? We'd end up with a shape that looks like that, right? And so we'd end up with a pyramid. And this is a type of pyramid called a square-based pyramid because the base, the bottom face, is a square. So what's the difference between prisms and pyramids? Well, prisms are very different than pyramids in certain key factors. For example, if you look at a pyramid, you look at all the side faces, not the base, all the side faces, you'll notice that they're all triangles. Well, when you look at a prism, all the side faces are all rectangles. In addition, when you look at a pyramid, they have one vertex at the top, while prisms will have 2 vertices. Right? So pyramids have triangular sides that all lead to a singular vertex. This can also be called the apex. Prisms have rectangular sides. So this is a triangular prism, so it has triangles, but it has rectangular sides. That's the big difference. Prisms have rectangular sides, pyramids have triangular sides that lead to a vertex. Now, one big term we're going to talk about is something called a polyhedron. A polyhedron is a 3D shape that is closed off, so it doesn't have any openings, and it has no round edges. So polyhedrons are 3D closed shapes with no round edges. For example, this guy would be a polyhedron. This is a hexagonal prism, because it's a hexagon and the rectangular side, so hexagonal prism. And it's a polyhedron because it doesn't have round edges, it has these straight lines. While a cylinder is not a polyhedron because it has these round edges. So it's not a polyhedron. And that basically covers nets, right? So what you would want to do is practice drawing nets. So I would recommend drawing a net for a cube because that one's pretty standard, right? Actually, I'll just type it out. right? A cube, right? A triangular prism, a triangular base pyramid, a cylinder, and a cone. I would like to try to draw nets for each of these shapes because these are the most common 3D shapes, and understanding how these shapes fold out allow you to develop a better understanding of surface area as well as volume. So I hope you found that useful, and I'll see you next class.